He is the lead IT security analyst at Duke Energy. He's fully accredited, so he's got the theory and the credentials, but equally important, he's got real-world experience. He's the primary security consultant to the Duke Energy Smart Grid program, which is certainly one of the country's most ambitious, so it's a big job with a lot at stake. By the way, he also previously spent time with the U.S. Army and with Michigan State. Rob, thanks again for joining us.
Hey, Jesse, thanks for having me. I really appreciate it, and thanks, everyone, for attending this. I just want to get started to say, this is just one guy's perspective, one utility's perspective, and I would say that we all have very different smart grid deployments and architecture, so some of this I definitely think is general. The thing I'd like to start off with like a baseline. Basically, security and vulnerability testing at our company is probably one of the most highly secure information that there is. So I'll try to talk as detailed as possible about these topics, but obviously, this stuff is very sensitive, so sometimes it might be a little high level. This first slide really just shows the key challenges the industry faces from a smart grid perspective, and I think most of us we've been hearing these for the past 3 to 4 years at least. And I'll just run through them briefly. It is a completely new architecture. We are extending our network beyond our traditional physical perimeter. We're using devices that really we've never used before. Also, another major hurdle here is validating your vendor security statements. What I mean by that is we would love to trust all our vendors, and you read their literature, you go through the processes with them, and everything looks secure. But really, we owe it to our company and our customers to validate those statements. Another thing, just to relate some stories, especially when smart grid really came on the scene, media coverage, things like Stuxnet and China, a lot of media coverage can really boil up and cause the proverbial fire drill at the company. So using and creating a good vulnerability and penetration program really sets minds at ease. And also regulators, that kind of ties in. Regulators, they read the media. They hear about, potential exposures. Basically doing your due diligence as a security professional to ensure that your company and your devices are secure, I can't stress enough. And then finally, just to bring it home, we owe it to our customers to do this work. We owe it to provide a safe and secure power grid. But we also have a lot of regulations coming down the pipe. I don't have a crystal ball, so I don't know which one might be adopted in the future. But you have regulations from like the AMI-SEC and NIST, like the 7628, and also most utilities have their own internal security standards. So really, where can we go? What can we do to ensure that our deployment is meeting those standards? I mean, it's one thing to provide architectural diagrams, review vendor security testing, but really where the rubber meets the road is actually doing the verification tests. And that's really what we're trying to drive home here. The most important thing to do to honestly say that your systems and devices are secure is to really perform the penetration testing on them. This slide really, is the kind of the core of the concept we're trying to talk about here. Performing and having a good vulnerability and penetration testing program really kind of leads you down two paths. You have a technical and programmatic. To relate kind of a story from my experience is we bring in, or we have our internal pen test folks do this extensive penetration testing, and they provide these great reports with tons of valuable data. But that also has side effects. It can also be used because some of these realms, like physical security and stuff, kind of pour over into manufacturing defects and design issues. So not only can we leverage these reports and this work that we're performing for just a pure security standpoint, it also, at our company, has gained a lot of attention from the engineers that are making purchasing and design decisions, because this valuable data about the innards of all this new equipment. Some of the other key points on the technical side is when you get these very sensitive reports, one thing to consider, and one of the hurdles you have initially is kind of trying to figure out how are you going to disseminate this information. It is the most sensitive information at the company from a smart grid standpoint, and obviously you don't want it getting legs and traveling all over the company. So one of the things we've done is really we try to break it up and sit down with the key stakeholders and go over our findings and basically relate the information to them. As far as risk assessment, Eric had a great statement on that. One of the things I found to really help is make good friends with your PMO office. They usually have a risk assessment team. Feed your findings from your security testing into that team and then track it at a project level. That can be very valuable and actually can ease up your time because you have someone else there to chase your findings. And lastly, on the technical side, how will the defect management be handled? One of the things you want to do is really, it helps build relationships with your vendors because you can actually feed them this information, and usually they're more than happy to get it because it's basically verifying their statements and allowing them to improve their product because obviously you're probably not their only customer. And then from a programmatic side, one of the things Eric touched on is we have new equipment, but now we also have legacy equipment and we have multiple vendors. So really, you can't look at it from a risk standpoint as just your new smart grid deployment. You really have to make sure that you're taking a bigger picture look at how all these new devices fit in with your current infrastructure and then perform your risk assessment based on that. The next point there, where to begin. This is a really interesting point because when you start off with a vulnerability or pen testing program in SmartGrid, you go for the biggest project. Well, I've found from our experience that you kind of start small and then basically you produce a quality information, quality reports that multiple departments around the company like. And then you get that buy-in, and then the next project, it becomes easier and easier as you go along. I kind of touched on this before, but the communication plan for this information, some people, when you're dealing and showing them these security findings, they're not used to seeing these reports. They're not used to seeing audit reports. Traditionally, they don't like to see, hey, I might have equipment that has something wrong with it. So really, what I mean by this point is walking gently. It's sitting down with the key stakeholders, explaining them, keeping them informed as you go through this process. And then once you kind of establish that baseline, it just makes it that much easier in the long run. And then the last topic here, who's actually going to do the work? If you already have an existing pen test team, can you leverage their expertise to perform your smart grid testing? Or do you look outside the company and go for a consulting firm that might specialize in smart grid testing and has prior experience? In the next slide, I kind of touch on that, but that's really one of the key decisions, I think, when you start up a program like this that really needs to be made. Okay, and here we really kind of break down the pros and cons versus leveraging internal resources versus external resources. And I'm kind of going to walk through each one and talk about the strengths and weaknesses of each. Internal resources, it's obviously you have people that are familiar with your environment, and you can leverage a lot of the existing tools that your internal pen test teams use. A familiarity with Linux. A lot of the new smart grid devices run on some version of embedded Linux or some flavor. You can use the same Wi-Fi testing. If you're testing Wi-Fi in your smart grid, is a possibility. Those same open source tools can be applicable back and forth. Things like Backtrack, we've had a lot of good success with. That's basically an open source security testing distribution. And tools that have been around forever, like Wireshark and Nmap and stuff like that, can all be used for the most part on smart grid devices. It's also a great experience for your internal teams. I mean, once they get this knowledge and they start become comfortable with these devices, really it just helps build a stronger internal team. And it's second to last there, it's fairly inexpensive compared to hiring an external firm. I mean, most of these people are already on the payroll, so really it's not a huge cost hit. Some of the negatives there, from what we found, is there's a wide realm of knowledge that when testing smart grid equipment. It's not just your traditional networking and application development knowledge. There's a lot of RF. There's a lot of cellular. It helps to have that background from an electrical standpoint because you need to know how the grid truly functions and how this device is, all the nomenclatures that go along with it. So that's kind of probably the biggest challenge there, is to find someone that has that overarching full knowledge. Now, from the external resources standpoint, especially in the beginning, I think a lot of firms look at it as a new revenue stream. And really, we went through this process probably almost 4 years ago, so it has changed quite a bit. And I'm sure a lot of people have gotten a lot more of experience. But at the time, we had firms basically almost willing to do this work very cheaply, but really hadn't had a whole lot of exposure to the technology yet. So that's kind of what you have to weigh. Do you want to pay the extra cost to bring someone in that's had smart grid testing experience, or do you want to pay the cost, the slightly lower cost, to let them get experience testing your equipment? And that kind of follows up on the second point there, the new revenue stream for big players. your larger consulting firms obviously see smart grid's not going away and can be very beneficial to get that testing experience. And just my opinion, from what I've seen from an external testing standpoint, the guys that have that well-rounded knowledge of all of those security realms and all the engineering background tend to be the most expensive, unfortunately. But you get what you pay for. If you want truly the most quality of work for your cost, I found it's kind of the way to go. Some of the other key points from an external testing standpoint, non-disclosure agreements kind of goes without saying that you obviously have to have those in place when dealing with this level of sensitive information. But one of the things that we had to do is basically outside of these testing programs, if you have external resources or even internal resources, you really need to set a baseline and say, even if you're testing next to someone, really we would prefer all this information be kept between just you and I or you and this key stakeholder. You want to make sure that you have a clear understanding that even a side comment to a colleague can be overheard. So really kind of drive that point home in the beginning. And then second to last there, getting internal people comfortable with a third party. It's a stranger. You're bringing people into your media labs. You're integrating security testing into people's work schedule that's already very busy. So that kind of goes back to what I mentioned before as far as starting with a smaller project and just getting those faces and that resource familiar around the company really can go a long way. And then one of the other things from an external standpoint, if you have internal resources, possibly bring them together. If your external resource is willing to have your internal resource do some of the work, it might not be a bad idea to have them kind of work together, and then you can get that knowledge transfer and build your internal team's knowledge of some of the areas they might be weak in, such as like cellular or embedded systems.